Alright, I just recorded that entire thing. It was like about 10 minutes long, but I erased it at the end, so I'm gonna do it again. It'll probably go smooth this time at least, but it's a bummer. Alright, here we go. So, you have a problem. You have 4 point, and see, like, here's all that old work. I'm gonna do it again from hand. 4.000 grams of a metal nitrate, so that's MnO3 They tell you that in the problem. They say you treat it with an excess amount of sodium sulfate, which is Na2SO4. Remember that Na is +1. You can look on the periodic table. SO4 is sulfate, it's -2. That's just a memorized thing, sorry. And then you do that reaction and you make 3.318 grams of a sulfate salt. And they're asking, well, what's this metal? And they give you a couple options. They say it can be Pb, lead, it could be potassium, it could be calcium, it could be barium, or it could be none of the above, but it is one of the above. I've confirmed that by now. I did the math, I figured it out, and then I cheated online, looked at some practice problems, looked at a multiple choice thing, here it is, and it told me I'm right. So obviously you don't want to pay to figure out what this answer is, so you don't get to explanation, you just get the answer if you look it up online. Alright, here we go. So first things first, I'm going to write the equation for this reaction. And so they say I react the metal nitrate MnO3 they say it's dissolved in water, which effectively doesn't actually change anything. It's not actually part of the equation. If you would write aqueous here if you wanted to, but I don't feel like it, so deal with it. Reacts with Na2SO4. And then you create a sulfate salt, which really says the sulfate combines with a different metal, sulfate salt. And we can write out this formula pretty easy. We know the charge of SO4 of Na, I already wrote those here. We also know the charge of NO3, that's another polyatomic ion nitrate, it's a -1 charge. And because of that, we know the charge of M. Every formula has to be electronegatively balanced. Basically, if this is -1 times 2, so -2. This has to be +2 if there's just one of these. So the charge of M is +2, which means we can cancel out this K. We know it's not K because K is a +1 and it's a +2. Ca is +2, Ba is +2, Pb can be +2, so those are still legit. But this is a double displacement reaction. This is your basic, if you have AB plus CD, it will react to form like that, AD plus CB. So they kind of switch partners. So we have M, SO4 come together. That's +2, -2, so it's just one of each. And then we have Na and NO3, which is +1, -1. Ah, poop. That's supposed to be a plus. There we go. Like that. We have to make sure the equation is balanced because that does kind of affect a little of this, but let's see here. I need 2 NAs and 2 NO3s, so I can put a 2 here. And then the rest of this is kosher. So you have the same amount of stuff on both sides. 1M, 1M, 1 SO4, 1 SO4, 2 of these, 2 of these, 2 of these, 2 of these. And they tell us I have 4 grams of this, and I have 3.318 grams of that. Okay? And in excess amount or an infinite amount of this, so you don't even have to worry about it, don't even take it into account. So here's kind of the basics of how I solved this and the thought process. One thing I saw was like, okay, first of all, there's a 1-to-1 molar ratio here. So if you have 1 mole of the metal nitrate, you should make 1 mole of the metal sulfate, as long as nothing else is holding you back. And in this case, there isn't. So this represents me putting in a complete amount, 4 grams, and then my product is a smaller amount, right? So there's there's a decrease between what I started and what I ended with. And I see that and I say, okay, well, the metal sulfate MSO4 is 3.318 grams. The metal nitrate, what I started with, was 4 grams. What if I make a fraction? Like, what if I try to find the percentage there? And if you do that math, you get something like 0.8. I wrote this down somewhere. There we go. 8295. So basically, the metal sulfate is only 83% of the metal nitrate. There's a 17% decrease there. And if your grams have a decrease of 83%, what that also says is that the molar mass of the sulfate, when you compare it to the molar mass of the nitrate version, it's hard to write with one hand, then this should also be 83%. It'll be 83% smaller, basically, 82.95. So if we're saying like the molar mass of the top was 82.95, molar mass was 100 on the bottom. That's the kind of math we're talking about here. That relationship holds. So I can kind of plug in some values for here. And what I mean by that is saying, if I think about what the molar mass of MsO4 is, right? I obviously don't know what M is, but I know what S and O are. I can say it is M plus S, which would be 32. I'm rounding a little bit there. And then plus 4 O's, plus 4 times 16 for each O, which will come out to M plus 96. If I do the same sort of math for the metal nitrate, right, I could do M plus nitrogen, which would be 14, the O3, so 3 times 16, an entire thing times 2. This will give me M plus 124. Right? Yes. So obviously I know some of the molar mass of each one of these. I don't know the M part, but I do know that there is an 82% decrease in the amount of product you have. So from reactant to product, there is only 83% kind of follow through, 17% decrease. That means that for me, the molar mass has to be 17% smaller as you go across. So I can rewrite this as the molar mass of MsO4, M plus 96, divided by the molar mass of M nitrate, so M plus 124. This is equal to that ratio that we see there, 8295. And this is just algebra. I can solve for M, you know, that's moving variables around. If I go M plus 96, if I take this up here, right, multiply both sides by M plus 124, then that'll equal out to, I'm going to distribute this out, so it'll be 0.8295 M plus 124 times that, which would be 102.858. Then I'm going to move this over, so minus 96 on both sides. M equals 0.8295 M. 102 minus 96 is going to be 6.858. From there I'm going to move the M over here. These are like terms, so I can subtract, add them if I want. So 1 minus 0.82 would be 0.1705 M is equal to 6.858. And then you just divide both sides by 0.17 blah blah blah. It'll give you M is equal to 40.22. And if you do that math, I did that math. So this tells me that the molar mass, that the mass of M is 40.22. So that this entire thing stays true, that 83% change between the reactants products, M has to be this. And so you just look at the periodic table at what these molar masses are. Pb is 207.2, calcium is 40.1, barium is 137.3, potassium is 39.1, but we already canceled that out, so get out of here. My rounding, I didn't like use all the decimals exactly, so it's not exact, but it is very close to this 40.1, this 40.22, so your answer would be calcium. That's about it. That's how I did it. It is a complex problem. It's kind of a pretty cool problem, but part of it, the crux is, A, can you write this out, the formula, from the information they gave you? And secondly, can you see this relationship right here? That if you have sort of a 17%, right, 17% decrease as you go across, that 17% gets reflected in other places, gets reflected in the molar mass. Because my moles stay constant, I should have 101. So the molar mass of this has to be 17% lower than the molar mass of this, if the weight of this is 17% lower. That's kind of what I'm talking about there, but there you go. Hopefully that makes sense. If not, holler at me. Maybe I'll try to clean it up a bit.